Alright, so in today's video we're going to take a look at how to add Bluetooth to a Becker special. This would be the BE2210. This one is fully furnished, doesn't have the screws out, so we can take a quick look at it. This would be the label I print out for it. I'll show you guys how to make one of these in the later part of the video. But also the first thing to keep in mind is, although this is a Becker 2210, oh, that's a mistake. Anyway, it happens. Similar models are also the Becker 1350 and 1650. So one of them is actually labeled classic, not special, but has the same button layout. So I don't know exactly the history behind that, but they are pretty much the same radio. All right, so let's get inside of it. Becker doesn't use screws for the top case, so it just unclips rather easily. All right, and just pulls forward a bit, and then you can take it off. So that's that, and inside you'll find the cassette mech, which has to come out, has 4 screws. These are taken out. Keep in mind that with this cassette mechanism, you can actually remove this little hook thing that opens the door. So the screw's right under it, and it pops off very nicely. It is a bit fumbly, especially when I'm looking through the camera, but anyway, you can take it out. Take all the screws out, and then you're fine. It unclips. There's a connector on this side. Not a lot of force, but anyway. And so this is what I've done inside. We can see that the power is coming from this board over here, goes into a 5-volt regulator module, and off to the Bluetooth module. The Bluetooth module has 4 wires that go to the buttons. So I'm using these 2 buttons for track control, so previous and next, and play pause is scan, which you never use anyway. So I'll show you guys how to get that done again in the future part. Now let's just have a quick overview. And then as for the signal, right, so the board outputs a single-ended audio signal, left to right. Actually, this is left, this is right, this is ground. We're using 2 capacitors to decouple the audio processor, because this actually has a signal path that is biased at, I think, 3 volts or something. So it sits above ground and oscillates right as the sound goes through it. But it is at 3 volts and this is at 0. So you have to block the DC somehow. And that's what these caps are for. They're rather expensive. I'm using 100 mic 6-volt caps. Some signal paths, I think even this one might actually stay at 7, so that's perhaps not optimal, but I don't know. Just the largest form factor SMD caps should be fine, and this nice little jar for it. Yeah. So what do we do next? Let's go over how the sound is actually injected into this radio, right? So what this chip does here is it's basically one of those mixers where you can select multiple sources, do volume independently for each speaker technically, right? So faders, get more sound going to the front or the rear, balance, more sound left to right, more volume, bass and treble, and it selects between the cassette deck. I think it might have an aux input from the CD changer, AM, FM. And so basically the processor tells it which source, what volume, everything, all of that. And we're injecting our sound onto it and using AM as basically a silent source. Because as you will see, there are 2 SMD components depopulated here. I'll show the actual installation diagram briefly, but these are taken out, and this would be how the AM sound gets into the chip. So with that being taken out, we're basically left with no sound on AM, and we can superimpose the Bluetooth audio onto a silent signal path, right? If we'd leave that on, it would be AM and Bluetooth in parallel. You'd just hear both of them. It would sound like complete garbage, obviously. So the first consideration when attacking such a mod is finding a voltage source that you can turn on and off with the radio or with the buttons. In this case, we have an AM demodulator chip. I don't know what it does. It doesn't demodulate because AM is, well, it does. I don't know. This IC that is concerned with the AM part, which has a 7 point something volt supply, which is off when you're in these modes and on when you're in AM, right? So basically when you switch this to AM, it will power up the module, the Bluetooth module, and it will connect to your phone automatically. If the radio's off, this chip is also turned off, so it's off completely. So you get in the car, the whole thing powers up. It remembers that you were in AM, so it connects to your phone automatically. You can just hit play from here or from your phone and just get driving. The warning the mention I'm talking about with set phone volume to 100%, this basically ensures that this entire signal path, right, these capacitors, this chip, is running at a voltage level that is suitable for it, right? The AM chip would output its signal at roughly a similar volume. If you would send a lower signal from this, you'd lose bass, different stuff, nonlinearities. I will not try to fool you guys into thinking that I know what I'm talking about, because I do not. And so anyway, this is a TDA3710, and we have the data sheet for it over here. It's a pretty old part from ST, 99. All right. And it should have the pinout over here, right? You see what each input is, and you can map them out and see what is which. In this case, I'll show you guys exactly where to connect to, so that's not going to be super necessary, but we see this block diagram. And I don't know which one is AM, to be very honest, but you identify which one is AM. For that, I actually have this little makeshift analog oscilloscoping thing. Let me try and find it. So for that, I basically made this, which has a clip for ground, a jack for headphones, and this pin here, which is molded out of this two-part epoxy thing, has a potentiometer just in case, and everything is AC coupled through this 1 microfarad capacitor, I think it is. I don't know. So anyway, you clip this onto the chassis anywhere and just start probing on the chips and on the tracks, and yeah, you'll hear which one is AM, you'll hear which one is FM, so on and so forth. So this has been quite valuable, and yeah, I think it has 5 years by now. Anyway, so you identify which one is the AM input, and you fuck up this capacitor, basically, right? All of these are AC coupled, again, because this sits at 7 volts, and on the other side, you can have a different bias or no bias. In the case of our Bluetooth module, there's no bias. It sits around 0 volts and oscillates around 0, right? This oscillates around 3 or 7 or whatever. Anyway, so you nuke this capacitor, and at the point in which the microcontroller tells the mixer to go to AM, this will have been nuked, so there is no sound. And what a lot of these mixer chips have is the main signal path goes out and comes back in, right? So there's these two capacitors, which I don't know exactly where they are on this board, but they're some of these. What you can do, though, is inject your sound over here, right? And so this is a very good start. In the case of this radio, I think I am actually disconnecting these inputs and plugging right into these. But in some different radios, I've just connected onto one of these legs, right? Either this one or this one, doesn't really matter. Doesn't really matter, right? So you have your Bluetooth output left or right, a capacitor, and then onto here. And that's how I've done a bunch of these. This one in particular, I don't know. Let's see. So 2210 would be the model. Boom. And yeah, so this would be how it looks. I like to use these brass standoffs, and these can be soldered right down onto the shield, stuck down with a bit of silicone so the nuts don't fly off from vibrations. And again, I recommend siliconing down all the wires so that they have no room to wiggle and vibrate and rip themselves off, right? Because if these wires will have a motion on them over the years, they will eventually snap off. So in the case of this one, I've applied a bit of silicone here on this longer streak of wire. Over here, right, there's a lot of sharp metal here, so all of this is flooded in silicone. Over here, and the wires are actually, this would be one of the most complicated mods because you have to lift one of these pins off. You can do this with an X-Acto knife, right? It's not super complicated. I'm not going to do it now, but right, you just go in there and flip them off. They do come off quite easy. So this is what has happened here. You can see this pin is actually lifted. It's connected to this wire, and obviously this is very fragile, so everything is held down by the silicone. And just to show you guys how well this sticks, I've done a demo patch here. All right. You can see it really is holding in, and trust me, I'm pulling super hard on it. I'm managing to free it ever so slightly, but keep in mind no one is gonna exert these kinds of forces on it. And the good thing with silicone as opposed to hot snot is it is extremely temperature stable. So you can run this at 100 degrees, which these radios, by the way, do run at, right? Everything here will be 100 degrees or 80 degrees. And so you can't use hot snot because obviously that will melt into a soup. So yeah, you can see this is really holding on, so it's perfect for these kinds of cable management situations, right? And they do stick onto this shiny metal, they do stick onto the PCB, onto plastics. It is very good. All right, so that being said, let's go on to actually how to connect everything, and we'll probably do a demo at the end, and I'll show you guys how to do the labels as well. So this would be a little overview of how I've used epoxy here. This is how everything is supposed to look. These are the connections. So ground has to be on this capacitor over here. Right can be stuck onto this via. Pop these off. I don't know why I haven't drawn that, but you have to pop these off, and you can see there's 2 tracks. Nothing from the other side, so that's fine. And so you don't have to lift this leg up, but this one you do have to lift off. So it's the first one going down after this one with the split over here, right? So just these two. Make sure to add the decoupling capacitors, which I've shown you in the jar. Otherwise, it will sound like complete garbage and you'll fuck up the biasing on the mixer chip. It's going to sound horrible. You're going to know that you screwed up, but yeah, don't run it too much in that mode. All right, and as for the power, right, we have this Siemens chip, which is made in Austria, back in the good old days. And this gets a 7.5 volt on AM, which will basically wake up our Bluetooth module, goes to this regulator, gets stepped down to 5, then goes into this isolating DC-DC converter, which outputs, I think, 5 as well. Powers the module, and you have a reconnect on startup event, which will connect it to the phone. Ground would be anywhere over here. In this case, I've stuck it down here, right? And I just cut a little bit. With the snips, right? I just section this, bend it down, fill it up with silicone so the wires don't get shredded. And that's about it with the power supply. This is a close-up of the pin being lifted. And again, I told myself here that I could just remove these. And that is it with the signal, right? Audio, power, and now we want the buttons as well. So this would be the front panel. This comes off, has 3 screws. You pop off the volume knob, it comes out very easily on these. So it's just this. Make sure not to rip the plastic because it's super brittle. And if your encoder doesn't work, I did a video on how to repair these as well. And so given that these buttons are multiplexed, so there's, let's say, 4 lines with 4 lines, and then buttons are at the intersections. So if you take one button out and you want to wire it with your circuit, you will have to reconnect the wires around it, basically. So in this case, it's somewhat simple. We just have to do 2 links. For the links, I'm using this tiny magnet wire. And yeah, basically one from this point up to this point. One more from here to here. Right. So hopefully there's a good shot of this. As for the cuts, there are 5 cuts apparently, so 2 are on this side. There's the super thin track over here, just nip it off. Same with this track, which runs under the resistor. And on the back side, 3 more. These 2 have to be disconnected. This one and this one. All right. And once you have the links in place and the cuts in place, you can solder 4 wires, right? The common, which is a 1.8 volt supply derived by the Bluetooth chip inside, gets connected here, next, previous, and play pause. And these wires, it's a pain in the ass to route them. I have them coming. Let me see if I can take this off. Right, I have them coming from this side. You can see that they're stuck to the places I've showed you. Make sure they go below the IC. And again, because this is sharp metal, you have to mitigate the risk of the wires tearing into the case, right? Because all of this is ground, so you will fuck up the buttons if one of them touches. So I just injected quite a lot of silicone with my patented syringe method, just to keep the wires nice and snug, right? The screw will come down here, but it's not going to protrude too much, and it's no big deal. And yeah, the wires basically go onto the Bluetooth module, and that's it. I should apply a bit of silicone on this nut. Seems that I haven't. Let's do that now. All right. Should be enough. And just leave a little pip. And yeah, what else? All right, so past Dari here, one more thing I like to do is at this point where you have the face open, you could actually very easily remove all the buttons. Becker did a really good job, and most of these buttons, except these and these, you can pop off pretty easily with the thing fully assembled, but with it being open, you can take some kind of a pry tool. Make sure it's not too sharp because this plastic is rather soft, and you can press all the buttons out very easily, like so. Let me zoom in. And right, I just give them a good clothing, and same with the volume knob, in case it's not too molten. If it is fully molten and has a layer of hard gunk on it, it's perhaps best to leave it as is, right? Because otherwise it gets all gooey again. And so anyway, the point is, these clips come out very easily, and then there's another longer clip here on which the whole thing hinges, right? So this presses on the button and then it hinges on this side. So yeah, these are very deep and tight in here. So what you'll want to do is unclip this and then pop this out like so. And there is a way to get these out from the front, but it's very aggressive and I do not recommend it. Just take out the 3 screws that the motherboard has and that the display board has, and then it will be much simpler. Right, so I'll remove one of these and then we'll get to removing the rockers for changing frequencies and tracks. Why am I not? All right. And so with these, right, the deal is one side has a little chamfer and the other one doesn't as much. I honestly do not remember which is which. Just pop this scan button out first, so that comes out easy enough. And then I think, yeah, so this is a bit firmer than this, right? You can see they created some kind of a ledge here as well. Yeah, this is perhaps the most dangerous button to take off. I've done it a couple of times. It's fine, but if these break, then it's a pain in the ass. I would recommend, right, if these are broken, because you do find them broken quite often, just try and, again, some sanitary silicone, which you can see dries rubbery. Just right from this side, try and secure these into place, and yeah, that's basically the best you can do. Boom. Did it survive? Yes, it has. Becker did a pretty good job on this. I am out of complaints. All right, so I'm trying to get some kind of a grasp on it with my nail, and on this side, just so I can pull on it as I bend this support. Right, so boom, I have it. Now this side, boom. And so the legs look fine, yeah. So I'll finish taking off the buttons, just some regular window cleaner, and put it back together. I'll also give the display a go clean, because, yeah, why not? I'll check the encoder, see if that's fine. If it isn't, I have a video on how to repair these. The repair doesn't last super long in my experience, so if you really are feeling fancy, you could replace these. The format is extremely standard, however, these encoders are very nice. So chances are, if you don't go on Mauser and just find a really proper one, Alps, whatever, I don't know what brand this is, doesn't say. But anyway, do spend as much as possible as you can on encoders. AliExpress and eBay ones are complete garbage. Anyway, back to Future Daria with his explanation and shit. Bye. Alright, so as for the label, I'm using Figma. Very nice app, very simple to learn. And I have all the different radios here with a bit of the user manual cropped out, so it looks, right, this image is cropped out from the user manual, just to showcase what the buttons are. Has a few sections, right, how to connect. There's a cool shortcut, Command Dot, which hides the UI. Let's go from top to bottom, right? So this will be actually cut off and you will have seen it, all right? It goes right on the radio. Let's see, let's go December. And this will always be modified on a per radio basis. In the case of this one, code is 21331, 21331. And I usually write the serial number as well, just in case it gets rubbed off. For the older Becker ones, it is actually stamped into the case on this side. So let me see if I can show it. There it is. Right, so that is very nice. Anyway, so BE, what is it, 2210? Just humor me for a while. V12, V12. And then the code is based off of these 5 digits, which in this case are 20554, 20554. And I also have to write it down here. So 21131. And a cool little party trick with Figma. Aside from the fact that it is fully free and works very nice and you can zoom into letters massively, right? So you can align stuff extremely precisely. Is you can round off the triangles. I think this is the coolest thing. So let's select this. And you can do the radius. Check this out. Is this not the most satisfying thing ever? Yeah, so let's leave it at 4. And yeah, basically this is how I print my labels. Nothing extraordinarily fantastic. This text is also taken from the manual, just to give people a little leaflet that they can have in their glove box. And yeah, that's about it. Just export frames to PDF, and then this you can print, and that's it. All right. So that's it with the Figma part. Let's do a demo. We could leave the cassette deck out. This radio does not mind it. So as for the power, I'm using my PD trigger, asking for 12 volts and just feeding into this little tester board, tester cable loom thing. Has ignition and backlight. So let's connect that. And boom. Code, what did we say? 21131. Oh, that's not actually right. Shit, I messed this up massively. Is the label okay though? The label's okay. 21331. So 21211. Fuck. 2133. Oh man, these buttons really are not okay. So I think this isn't clipped on properly. We'll see. 21331. 331. Okay. And once you go to AM, you'll see these light up because we have the 7.5 volts over here. So let's see. Boom. And now the Bluetooth module will enter pairing. And in order to program the Bluetooth module to have a proper name, I'll again link a video at the top. So that should not be a major issue. You do need some programmers and stuff, but it is definitely doable. And yeah, I think we're about done. We could first set the volume to 100%. All right. And it does work. Now let's see the buttons on the front. So play, pause. And the buttons are really wonky on this. Like super wonky. Yeah, anyway, they were supposed to work. Let's see if track skipping works. Well, going back does. Going next does, but play pause doesn't. Yeah, I'll have to see what's up with this face. I haven't tested it actually before this video, so yeah. This kind of stuff happens. These radios are from 97, so yeah. So with that being said, right, the config of the Bluetooth chip, the buttons, the front panel, everything should be covered. That's been it. Let me know if you guys had any success stories with these, if anyone has followed this tutorial and has got it done. Any questions, also down in the comments, and have a good one. Happy holidays. Bye.